Out in open water, white foam suddenly erupts from hidden nozzles across the carrier's flight deck, spreading in thick rivers over gray steel. Sailors guide the flow as it builds, layer upon layer, until the entire 4.5-acre deck disappears beneath the dense white blanket. Within minutes, the carrier looks transformed. Its runway is now buried under a pale shield from bow to stern. This is a full system test of the carrier's emergency deck protection network. Thousands of gallons of specialized foam can smother a crash fire before it races through parked aircraft or seal the deck against contamination that lands with the next recovery. It looks like science fiction made real, and it proves that modern carriers can literally grow their own defensive skin when danger arrives. A carrier flight deck is a runway built inside a moving weapons yard. Every launch cycle stacks hazards on the same patch of steel. There are jets parked close, tanks full of JP-5, engines spooling hot enough to shimmer the air, and bomb carts rolling past tow tractors and fuel hoses. The ship never stops. On the deck, people come and then go. Beyond the foul line, there's nothing, just open water, while another launch rolls in behind. Once things catch fire out here, it acts nothing like flames on solid ground. Instead of sinking into dirt, the fuel gathers and spreads over level areas, shifted by how the vessel moves, stirred up by gusts and engine exhaust. If a container breaks or is struck, even a small amount of liquid can explode into a fast-moving wall of flame almost instantly. If the fire hits planes that are parked or weapons nearby, the whole area could blow up at any second. The worst-case scenario actually happened in the 1960s. On July 29, 1967, while on board USS Forrestal, a Zuni rocket went off by mistake above a packed flight deck, hitting an already fueled plane. Because of the collision, a fuel tank broke open, JP-5 leaked everywhere, then suddenly caught fire. Fire spread across the steel almost instantly. As the heat climbed, bombs and rockets on nearby planes detonated one after another. Each blast tore open more fuel and threw burning debris into new areas. By the time the fires were under control, 134 sailors had lost their lives, 161 were wounded, and more than 20 aircraft were destroyed. 2 years later, on January 14, 1969, USS Enterprise suffered another flight deck inferno. It all happened after a rocket detonated and set off further munitions. Around 18 explosions tore holes through the deck, took the lives of 28 sailors, injured 314 others, and wiped out 15 aircraft. Different ships, same lesson. Once a deck fire starts moving, it stops being a fire and becomes a cascade. After those disasters, the Navy needed a way to cover a carrier's deck faster than fire can run. As such, they developed a system called deck-wide washdown that relies on a substance specifically designed to prevent burning jet fuel from spreading across a flat deck. In the early 1960s, the Naval Research Laboratory worked with 3M after test runs showed that water couldn't extinguish carrier fuel fires quickly enough. What they produced was a thin, fast-spreading foam that lays a light water film over fuel. The film traps fuel vapor and blocks oxygen from reaching the flames, while the foam blanket cools the surface and helps prevent reignition. The first version was nicknamed Light Water. Once it moved from the lab into fleet service, the Navy standardized it under the name AFFF, Aqueous Film Forming Foam. The formula was patented in 1966 and became fleet standard because it could knock down jet fuel fires at the speed flight decks required. In most situations, AFFF is stored as a liquid concentrate and mixed with water. The proportions are usually at 3% or 6%, depending on the equipment and the threat. It's then pushed out through whatever gets it onto burning fuel the quickest. Crash fire trucks on airfields, hose teams on deck, fixed monitors, or overhead sprinklers in hangar bays. Once AFFF spreads across the spill, it seals it off from the air and keeps the flames in place rather than letting them spread. It proved its value in real conditions just after midnight on May 26, 1981. An EA-6B Prowler crashed during night operations on the USS Nimitz. The impact ruptured fuel tanks, and JP-5 began running across the deck. Soon, the flames pushed toward parked aircraft loaded with live missiles. Firefighters advanced through the smoke, while hose operators maintain cool equipment temperatures. Meanwhile, the vessel's flat deck and side-mounted foam system prevented the spread of flames, limiting damage to about 4,000 square feet. The primary fire was controlled within roughly 30 minutes. Still, teams remained much longer, tackling lingering hotspots, smaller flare-ups, or possible late explosions until the area was fully secure. So the next step was obvious: build a ship-wide way to spread that protection across acres in seconds. Since the only other time the system runs at full force is during a real emergency, the Navy tests it routinely to make sure every nozzle, valve, and line will work on the day there's no room for failure. One of these washdown procedures was captured in a short, sped-up clip shared by the crew of USS George H.W. Bush, meant to show what a full deck run looks like on their ship and how the team carries it out at sea. The clip picks up mid-procedure, when the runway is already turning white. Shared by the crew on August 15, 2016, it shows sailors moving in lines across the landing strip on open sea, working from a pile of gear staged near the bow. They grab hoses from that forward work site, walk them back across the deck, and lay down coverage in wide swaths. Even with the ship rolling, the motion stays steady and practiced. Section by section, the gray steel disappears under a pale coat. At one point, an aircraft gets inched forward toward the front of the ship while the coating continues around it. Deck tractors and carts sit pushed aside, waiting for their turn. Then, the ship's fixed sprayers take the edges. Perimeter nozzles fan mist inward across the surface the crews have already covered, thickening the layer into one continuous field. Wind over the deck lifts the foam into a low, rolling cloud that slides across the island. From a distance, the carrier looks half-cloaked, moving inside its own white haze. Along both sides, the runoff spills overboard in continuous sheets. It pours like waterfalls, breaks into curtains in the wind, and streaks down the hull in bright trails. The ship looks like it's shedding its skin into the ocean. This kind of full-system washdown on a Nimitz-class carrier is usually done about once a year. Crews run a foam and seawater mix through every zone at once, using on the order of a few thousand gallons of concentrate to coat the hangar bays, flight deck, island, and fantail. More than 200 maintenance checks come first, because outside this annual run, the only time the whole system fires together is during a real emergency. On a carrier, a fuel fire or contamination can spread in moments, which is why the deck needs to be sealed fast before the situation grows. In a crash or explosion, washdown floods the surface with foam and seawater, cooling hotspots and pinning the fire to the spill area, while crews pull aircraft clear and secure weapons. Navy damage control doctrine also treats washdown as a practical countermeasure for CBR threats, such as chemical, biological, and radiological contamination. If a chemical agent lands on the deck, the risk doesn't stop after the first exposure. It can seep into seams or cling to equipment, then get tracked below on boots and tires. Washdown helps by diluting the agent right away and flushing it overboard before it has time to soak in or spread. Biological contamination works the same way. Particles can settle on the runway or cling to equipment, then get stirred up again by jet blast. Keeping the deck wet and foamed makes it harder for material to stick in the first place, and it also cuts down on what gets thrown back into the air. Radiological dust is slower, but it still threatens flight ops. Fallout can settle on flat surfaces and remain until stirred up by rotor wash or exhaust. Washdown binds those particles to water and carries them off the ship, keeping the deck usable. If contamination ever hits a carrier, the response starts immediately. An alarm is passed, and the ship shifts into a sealed condition. Crews move through the interior, securing boundaries, with special attention to anything that vents to the outside. The primary targets are the fittings, marked with a black W inside a circle. These are Circle William fittings, outside air ventilation openings that are normally left open, but are shut when chemical, biological, or radiological contamination is possible. Once they're secured, outside air can't be pulled into the ship. With the ship sealed, the washdown system kicks in. Pumps force the water and foam mix through the lines. Deck edge nozzles open, and the spray spreads over the flight deck before washing along the island and the rest of the ship's exterior. The goal is to remove contamination while it's still on the surface, before it settles into seams, before it gets carried below on equipment, and before jet exhaust can start it back into the air. Sealing the ship and washing the exterior are designed to work together. In the early Cold War, Navy crews were already training on the same basic idea. A 1953 chemical warfare defense film shows ships using water curtain washdowns to flush radioactive fallout and chemical agents overboard as quickly as possible. Back then, the main fear was radioactive fallout, but the same training also drilled crews on chemical and biological attacks. A key segment tells soldiers to pay careful attention if they, quote, want to live through a nerve gas attack.